Hi everyone, I'm Dr. Migara Lienage presenting the research activities of the Department of Mechanical Engineering. I would like to start with the development of a hybrid powertrain for a three-wheeler. This research is conducted by Dr. Malika Pereira and Mr. Varno Madhumake. So the main objectives of this project is to investigate the effect of hybrid configuration and drive cycle on fuel consumption and emissions, establish an optimal power management real-time control strategy. Through this study, it is expected to investigate the fuel use and emissions with different powertrain architectures for three-wheelers operating in urban areas, develop an optimal controller considering gear shift and power split ratio of a three-wheeler, then to establish a systematic and easy to implement methodology to develop a real-time near-optimal rule-based strategy. So when you consider the progress so far, this research has completed the design for developing a hybrid powertrain for a three-wheeler. It has carried out fuel and emission analysis considering the powertrain configuration and drive cycle. It has developed an optimal power management strategy using dynamic programming. And finally, a rule-based strategy was developed from the dynamic programming results. So I would like to show some key results from this study. Fuel consumption and emissions analysis for different driving configurations and drive cycles have been studied. So it shows that the compared to series hybrid configuration, the parallel hybrid configuration performs much better in urban drive cycles. And also reduction of fuel does not necessarily indicate a reduction of emissions with a hybrid electric powertrain for a three-wheeler. So these findings have been presented in a journal paper in Journal of Science and Technique. Then in the next study, a near optimal power management strategy for hybrid three-wheelers have been developed. So the findings of this study will be published in Energy's journal. Now, according to the findings, it shows that the parallel hybrid powertrain proposed for three-wheelers under Sri Lankan conditions can reduce the energy consumption by almost 55%, more than 50%. Let me move to the research that I am involved in. The main area of my research is energy consumption and climate change mitigation. Under this, there are two main projects. So let me first cover the first project, which is real-time domestic energy optimization for energy conservation using AI techniques. The team members are myself, then we are collaborating with Dr. Chitra Langamana from University of Waterloo, Canada. Then Mr. Madhava Herath and Mr. Taksila Tilakanayaka are the other team members for this project. Objectives of this study are sensorless domestic energy signal disaggregation using deep neural networks and domestic energy optimization using reinforcement learning. Through this study, it is expected to disaggregate the household electricity consumption into device-wise energy signals, then to develop a real-time data logging devices for monitoring household energy consumption, collect an appliance-wise energy data set for Sri Lankan households, suggest countermeasures for domestic energy consumption, and develop a domestic consumer advisory model for energy cost minimization in a time of day tariff environment. So let me present some key results. A comprehensive analysis of convolutional neural network models for non-instructive load monitoring was carried out. So this study showed that developing a classification-based parallel path software association approach showing a significantly better performance than other convolutional neural network architectures. Signature uniqueness is significantly powerful in disaggregation than volume of training data. No strong evidence showed that the existence of individual relationships between appliances and disaggregation models. Then the disaggregation performances mainly depend on the type of CNN models and the uniqueness of the activation signature. Based on this study, the outcome of this study was presented at the ICU conference held in Thailand last year. So these are some of the results. I'm not going to go into detail due to the constraints of time. So we are planning to complete the following tasks during 2021-22. We are planning to develop an AI-based model for real-time self-learning energy disaggregation. Then we are planning domestic consumer advisory system for energy cost optimization in a time of day tariff environment using reinforcement learning. Then we are planning to develop the first ever Sri Lankan domestic energy consumption data set. For this, we require a data logger. Design and development of the data logger is completed, and also develop a real-time domestic faulty electric appliance identification model, which is almost complete. Then we are also planning to take this research to various organizations like CB and PUCSL and get some sponsorship. And we are also planning 8 journal and conference papers. Especially we are targeting journals with high H index so that it will give some recognition to our work. Then the second thrust area that I'm involved in is energy economic environmental modeling for climate change mitigation. The team members of this research are myself, Professor Rahul Atalage, Professor Chandana Pereira, Professor Shiromi Karunaratna, Ms. Gayashika Fernando, and Mr. Janit Vijayasinghe. So the main aim of this project is to develop an carry out climate policy assessment through energy economic environmental modeling for Sri Lanka. So the objectives of this research is to develop an energy economic environmental system model for Sri Lanka for the period from 2020 to 2050. Then to carry out the analysis of environmental and economic implications of nationally determined contributions for Sri Lanka. Then to find out the role of carbon tax in achieving the 2-degree centigrade target, which is set out by the Paris Agreement. Then to estimate the energy and environmental implications for different emission pathways using the energy systems model developed by us. Finally, we are going to analyze some scenarios that will take Sri Lanka to carbon neutrality. So this is the framework of the model that we have developed. It considers both energy supply and energy consuming sectors in the whole economy. So I would like to now present one of the studies that was presented in the ICU conference held in Thailand. This considered the potential role of carbon tax to achieve Paris Agreement targets. Under this, we considered 3 different carbon tax rates for Sri Lanka, and these carbon tax rates, these carbon tax scenarios have been presented in a global database where the countries could implement. These 3 scenarios are referred to as TAIM, TGCA, and TREM scenarios. So in this study, we saw that under the business as usual scenario, the carbon dioxide emissions will increase from 20 metric tons to 106 metric tons at an average annual growth rate of 5.1%. And we see that by 2050, the TAIM scenario will be the most effective, and it could reduce up to 25% of the GHG emissions as compared to the base case. And when we consider the contribution from different sectors, we see that in TAIM scenario, the power sector will contribute almost 62% for reducing carbon dioxide emissions, and this will be followed by the industry and transport sectors. So considering the plan during 2021 and 22, we plan to complete the development of scenarios leading to carbon neutrality in power, industry, and transport sectors by 2050. Then we plan to complete the development of different emission pathways according to the IPCC guidelines on shared socio-economic pathways. Then finally, we plan to complete the estimation of marginal abatement cost of carbon dioxide reduction and analysis of co-benefits of carbon reductions. And then we plan to promote collaborations with Sustainable Energy Authority and Climate Change Secretariat and CEB, so that uh, it will give some recognition to our research from these government organizations. So we are planning 2 journal and conference papers from this research in the coming year. So as I mentioned earlier, we are planning very good journals with high H index this time. Last year, we were successful in producing 3 international conference papers. So these are the papers that were presented at the ICU conference held in Thailand. So thank you, everyone. Thank you very much, everyone, for listening.